We both know computers store information using ones and zeros, both of which are represented using either electricity or a lack of it. But when all the power goes, isn't it kind of funny that the computers still know which bits are meant to be ones? How does it do that? Before we begin, it's important you really understand the difference between primary and secondary storage. Primary storage, aka random access memory, aka RAM, is super fast memory, literally centimeters away from the CPU, that stores stuff happening right now. Anything happening right now is stored in the RAM. This memory is called volatile because it does forget everything when the power goes, and that is by design, or else turning anything off and on again would never fix it, and then I'd be out of a job. That's not what we're talking about today. I mean the fact that I could take a selfie, turn my phone off, dunk it in water, leave it in rice for a bit, then throw it down the stairs, but when I unlock it, the selfie is right there. Well, ladies and gentlemen, may I introduce to you secondary storage. This is slower, non-volatile storage, a lot further away from the CPU. Keyword here being non-volatile, meaning it doesn't lose its data when the power is lost. But that doesn't really make any sense, does it? Yeah, actually it does. Let's take a look at a few. Firstly, we have the cards with holes in them. If you're confused, check out this video, but a brief summary from that being computers from way back in the day before USB, MacBooks, and AI slop use punch cards to store data, with the ones and zeros being literal holes or lack of holes on this card. They obviously don't need power because they're just cards with holes cut out. Next, we have the optical storage like CDs, which can hold about 700 megabytes, and Blu-rays, which range from about 25 to 50 gigabytes. This form of data storage uses a laser that hits the shiny part of the disk. If we just zoom in on here, it has a pretty interesting pattern of lands and pits, which ding 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 represent our ones and zeros. The laser reflects light differently when it hits the land and when it hits the pit. As a result, the laser sensor in your disk reader can attribute the different reflection values to either a 1 or a 0. This form of storage is pretty top-notch, using stuff like console games and movies, but read speeds are a little slow to use it as your main driver, and write speeds are borderline non-existent. So for day-to-day use, I probably wouldn't recommend it. And the fragile nature of it makes it super prone to things like dust and scratching, which would literally scrape the data off the disk as the pits and lands get deformed, which as cool as that sounds, doesn't really make for good long-term storage. Next, we have magnetic storage, which really only uses, well, magnets. Data is stored as tiny north-south poles on a spinning disk, and a read-write head moves across the surface to detect and change those magnetic states. A lot of information in 2025 is stored on magnetic disks. From backups to archives to data centers and game libraries, the read and write speeds for these are actually pretty solid too, so they could be used as your one and only form of secondary storage in the early 2000s, but nowadays you're probably better off using flash. Which brings me on to the most confounding one, flash storage. And this works using black magic. Anyways, thanks for watching, bye! Lol, as if. On a real note, flash storage doesn't use spinning disks, lasers, or magnets, as cool as that would be. It uses tiny transistors, billions of them, called floating gate transistors. Each of these transistors can trap electrons inside of a little insulated layer. Once those electrons are stuck in there, they could basically stay there for years without power. So no electricity needed, no moving parts, just electrons being where they've been forced to be. If the transistor has trapped electrons, that's a 1. If it doesn't, that's a 0. I'll link a super awesome video in the comments or something explaining the chemical and electrical engineering behind it. I did grossly oversimplify what is happening here with the whole trapped electrons thing, but you know, if you want more information, just watch that video. So going back to our earlier scenario, when I turn my phone back on, it really just checks whether each transistor has a charge trapped inside of it or not. This is what makes flash storage so good, all right? It's so fast, it's so quiet, and so shock resistant. Like I said, I could toss my phone down the stairs and, you know, because none of that scraping the data is happening with the CDs or physical magnets moving around, there is no issue, which is why this would be used in things like phones, SSDs, USB sticks, basically everything in modern computing. However, this power does not come without a cost. Flash actually does wear out over time. Every time you write data, you put stress on the tiny transistors and they can't hold electrons very well. So SSDs actually don't last forever. But realistically, they'll outlive your laptop or phone anyways. So it's not really black magic, but does kind of feel like it. Anyways, thanks for watching. Bye.